Good afternoon, everybody. This is Tim Heidel at ARPA-E. I'm a program director here at ARPA-E, and I'm leading ARPA-E's efforts to explore whether or not to run a grid optimization competition. I'd like to start by really thanking everyone for joining us this afternoon on this webinar. Our purpose of holding this webinar is to provide a forum to ask questions and get clarifications on any of the content in the formal request for information that we released a couple weeks ago. As you'll see in the request for information, ARPA-E has been scoping and exploring the possibility to run an algorithm-focused competition related to grid optimization, starting with a focus on the optimal power flow problem. We've tried to lay out in the RFI that we released pretty much everything that we know so far. And the idea was to try to release a straw man that folks could respond to and provide detailed feedback where we try to make it clear throughout the RFI where we feel we still have theoretical gaps or we don't have enough information to make key trade-off decisions in the design of a competition. We're excited to get your questions today, excited to get some of your feedback on this webinar. I suspect we're going to run out of time, so I am more than happy to do individual phone calls or follow up over email with everybody over the next couple weeks. However, I would ask that you do not use this session or individual conversations over the next couple weeks, if desired, as a substitute for formally responding to the RFI. RFI responses at ARPA-E are going to be critically important in helping ARPA-E decide, first, whether or not to proceed with running a competition, and second, on exactly how to design that competition. And so I will be using a lot of the content in the formal responses we receive in pitching this concept and moving it forward on a continuing basis with ARPA-E's leadership team. So those formal responses are quite important. I have put together a brief presentation that steps us through all the content, or a lot of the content at a summary level that's in the RFI. I would welcome questions throughout the presentation, really focusing on aspects of the design of a competition or recommendations you might have on how to make the competition most impactful. Our host today is Natalie, and do you want to introduce yourself briefly?
Hi, this is Natalie Joubert. If you need to ask a question at any point, please feel free to reach out to me in the chat. You can just send it to my name, Natalie Joubert, and I will alert Tim here. You should all be muted, but I also remind you if you're not speaking to mute your line as well so that we can minimize any bad audio or interference. Thank you.
If you do like to ask a question, we will try to unmute you and allow you to actually ask your question to the webinar. I think that's going to make things flow easiest. So let's dive right into the content. I think many of those attending today have perhaps seen presentations given by myself or colleagues over the last years. We've started to develop this program, and really for the last 18 months or so, we've been focusing on the need for new algorithms for optimizing power flows in a grid. And I think everyone is well aware with just how difficult that problem really is. Let me see if I can go to the next slide. And so there have been, of course, sophisticated pieces of software that have been developed over the last several decades. And underlying all of those is a requirement to make a large number of simplifying assumptions and or adding iterative heuristic-based solution methods. Those are simply required to achieve reasonable solutions, of course, within the time constraints required for grid operations. Today, our understanding is that there is no commercial tool that can fully utilize all of the network control opportunities that one might want to take advantage of, including everything from generators to transformers to emerging power flow control devices or power electronics, voltage set points at various devices, capacitor banks, etc. And since OPF historically has rarely been used in the context of distribution system operations, existing algorithms that are widely used today are unlikely to scale to the scale of the resource numbers that we're likely to see in distribution systems. And so this gives a rise to, first, there's probably a lot of benefit. We expect there's a tremendous amount of benefit from achieving more robust, faster, and more scalable algorithms, even for the transmission problems we've always dealt with, especially in the context of high penetrations of renewables. as well as there's a lot of potential impact in the application of OPF into distribution systems as well. So of course this has been a hard problem. It's been a problem that's been worked on for over 50 years, and it's been the subject of a tremendous amount of work in the research community. So why do we think we could have an impact now? And I think as I've talked to the research community over the last several years scoping out this program, I really boil it down to 5 different recent advances that I think could give rise to the potential to see a step change in performance in these algorithms. Of course, this is on the platform of continued reductions in advanced computing costs and rapid improvements in solvers, work that's been done on reevaluating alternative problem formulations and alternative ways of modeling the problem, and then of course new approaches to actually solving the problem that rely on various flavors of convex relaxation, and we've seen some evidence in the literature that suggests that distributed approaches could be pursued for achieving OPF as well. Just 2 snapshots here from recent literature showing the reductions in computing costs as well, and then one particular example of how reformulating the problem can allow you to improve the probability of convergence or speed up the solution time as well. We think that some combination of these 5 factors, and it's not necessarily all 5 together simultaneously, give us an opportunity to explore new OPF algorithms that could scale for distribution systems and to handle a lot more of the complexity and the control devices that exist out in transmission systems. And yet, despite all the work that we've seen in the literature over the last couple of years, and despite being pitched by a huge number of different organizations on these algorithms over the last couple of years, these methods, unfortunately, are struggling to gain real industrial traction. And when we started to scope out why that was, we really came up with 2 hypotheses for why these methods are struggling. First is that existing public R&D data sets are simply inadequate. There's too few of them, they're too small, they're too incomplete, they're too easy to solve in some instances, and they're not representative of real systems. And we launched a funding solicitation last year and a new program at ARPA-E called Grid Data that is trying to solve that part of this problem. In this program, we have funded a number of project teams to develop new synthetic large-scale validated and open access power system models that can be used by the early stage R&D community for benchmarking of early algorithms. Each one of those models is going to look slightly different. It's going to have different levels of complexity. We're very hopeful that we'll be able to, with that program, put a whole new generation of benchmark systems on the shelf that can allow for both transparent repeatability of research as well as comparing across different solution methods. However, I'm not sure that goes all the way to the final solution. Today, there does not exist a rigorous way to compare existing tools and compare new methods against each other. It's been well reported that some new algorithms that have been proposed, and this happens not only in the OPF domain, but many others as well, poorly handle many of the complex real-world constraints or requirements that industrial applications really do have to handle. Slight changes in assumptions that can be quite subtle can vastly change the outcome of a calculation. And so it's very, very difficult, even when comparing papers by different groups under different settings using the same benchmarking model, it's difficult to ensure that the comparison you're looking for is actually a truly apples-to-apples comparison. So we started to think through how we could enable a rigorous way to compare new methods to each other and to clearly identify the relative strengths and weaknesses of different methods for different problems, and came to the conclusion that the most effective way to solve that problem is likely through a competition. Prize competitions have been used in a wide variety of different industries for a very long period of time, and they've been really gaining in prominence over the last 10 years or so. Our sister agency at DARPA, of course, also uses prizes quite effectively for a wide variety of different problems. In most of these cases, you find by running a prize, you leverage first a huge amount of resources that you probably would not be able to leverage through a traditional funding program. And you also tend to identify and find solvers that exist well outside the traditional community and the traditional subset of folks you think could solve a given problem. So we are hopeful that that will happen here as well. But in order to do that, we need to very carefully design the competition and ensure that it is accessible to a wide variety of solvers, even those that do not have specific domain expertise within this particular field. And that's one of the things we've really been struggling with over the last year, is to find ways to present the problems that need solving to a community of solvers that do not necessarily have 15, 20, 25 years of experience in the power systems domain. That led us to the launch of the RFI that is available, and I think we emailed this to everyone who registered for the webinar earlier today. You can also download it from the ARPA-E website. And the goal of this RFI is to lay the foundation for a program at ARPA-E accelerating the development of comprehensive evaluation of new solution methods, and provide a platform for the identification of transformational and disruptive methods for solving power system optimization problems. In designing a competition well, we need three things. First, we need realistic and challenging benchmarking test systems that can be shared publicly and widely, and that is what we're trying to accomplish with the grid data program that we launched earlier this year. Second, you need a detailed, accessible problem definition, and this is really a trade-off decision that has to be made. You need to make this sufficiently complex to be valuable to the industry itself, but it also has to be accessible to non-domain experts. If we make this extremely realistic and we try to model every last detail, we very quickly can shrink the pool of potential competitors down to one or two or maybe three companies worldwide. Of course, if we remove a tremendous amount of that complexity such that everybody in the entire community and adjacent communities can make credible entries to the competition, then we've removed enough complexity that the algorithms that result are unlikely to be industrially useful. That problem definition also has to lay out very clear objectives and describe the desired solution characteristics in a quantitative way. We need to use consistent and clear modeling assumptions, and then have a transparent and quantitative scoring criteria. So a lot of our RFI details that we'll go through in this webinar, you'll see, are really focusing on laying out that detailed and accessible problem definition. Finally, the third piece you need is a fair solution method evaluation platform, especially for problems in which computation time and relative computation time between different methods is critically important. It's important that we ensure some repeatability of the results, and therefore we've chosen to set up an automated evaluation and scoring system that uses a consistent computational platform across all of the competitors. We also are planning to employ a separation of data sets for training and actual competition data sets that will be scored upon that all of the competitors will have never seen before. And then that same online evaluation platform will also have a public leaderboard to promote active participation throughout the competition process. So what I've tried to do so far is motivate a lot of our high-level intent and our motivation. Most of the rest of the webinar is going to focus more on the details of what we actually are planning on doing and what we know so far. Let me re-emphasize the importance of providing written feedback to ARPA-E through the formal channel of the RFI. Please feel free to answer only a small subset of the questions that we've asked in the RFI, or answer them all. I also don't want to limit everyone to only answering the questions that we've explicitly called out and given a number to. If there's some other fine detail that's described somewhere in the RFI that you think really could be improved or is a major cause for concern, please bring that to our attention. We want to fix those as fast as we possibly can. So before I dive into the details, let me stop here and see if we have any questions so far. Okay, so feel free to send your questions via the chat box to Natalie, or at least indicate an interest in asking a question, and we can try and unmute you. And I will distribute the slides afterwards, so you will have these slides. Although we've tried to keep the content of the slides almost identical to what's in the RFI. So first, let me provide a high-level overview of the structure that we're envisioning for the initial competition. So far, what we're laying the groundwork for is a two-phase competition that starts next spring. And the first phase is the one that we're focusing primarily on at the moment, trying to lay out a clear optimal power flow problem to be the foundation of that first phase. The Formal competition would be announced in the spring if we decide to go forward. We would hold 2 mock trial events, one in the summer and one in the fall of 2017. And this would be scored just like the final event. It would be using a data set that had not previously been released to the public. That data set will then be released publicly after the conclusion of each trial event. And the goal here is to really ensure that there are no problems with the interaction between competitors and the evaluation platform to really work out any of the bugs that might be found in that platform as early as possible and certainly well before the finals event. The platform itself will be open continuously for scoring submissions from competitors against any of the data sets that have been released thus far. And we'll go into the data sets in a couple slides. As I said, in phase 1, we're thinking we're going to focus on a particular version of the preventative security constrained OPF problem. And we're asking competitors to provide controllable resource set points to meet system load at least costs in the base case. They're also secure against specified contingency scenarios that will be specified in the data sets provided. And we've selected thus far a particular way to model post-contingency generator responses for both real and reactive power. We'll go through those in some more detail later, and it's also laid out in quite a bit of detail in the RFI itself. We really haven't made any specific or final decisions on exactly what to look for in phase 2. Phase 2 could be simply a more sophisticated or complex version of the OPF problem with more controllable devices or more complex assumptions around generator characteristics or capabilities. But the other way we could go is to focus on the unit commitment problem. Keep in mind that the way that we are posing the optimal power flow problem does include discrete variables. And so you'll have to be able to deal with discrete decisions in the first phase. And then, of course, you'd have to also work with binary variables in the second phase if we were to go through a unit commitment problem. This would add power system network models augmented with additional generator constraints such as ramp rates, startup and shutdown costs, and other details that tie the whole day together. And it would be a multiple period optimization or multiple interval optimization problem. We have not yet started to develop the detailed formulation for that problem, but we are very open to recommendations. In particular, we would really appreciate being pointed to any formulations of this problem in the literature that have been published that stakeholders feel are particularly strong or particularly comprehensive and would be the basis of, or could be the basis of, the subsequent competition. We are very much looking forward to feedback on what we should focus phase 2 of the competition on. The idea is that phase 2 of the competition would also consist of 2 trial events and then a final event. And we'll talk a little bit about how you compete and different tracks for competing later. But at this point, we do not anticipate that you would be required to participate in phase 1 in order to participate in phase 2. So each phase, we're envisioning we'll have 4 data sets. And what do I mean by a data set? A data set will consist of several and hopefully a large number of different network descriptions. And each of those networks would also have a large number of individual time snapshot scenarios. So in the RFI, we're calling those network scenario pairs. So each network scenario pair represents a given network or a given system at one instance in time. In many of our grid data projects that are currently ongoing and getting up to speed, we've asked teams to prepare 1 or more networks with a full year of time-coupled scenarios. And so in theory, we may have some networks for which we have high quality, at least 8,760 hourly scenarios, or possibly even more than that. We're really hoping that the competition here will be based on a very large number, solving a very large number of network scenario pairs such that we can truly tease out the performance of any given algorithm. In each phase, we plan on releasing an initial original data set that will have, it'll introduce the format for all of the data, and that will be made available right at the beginning of each phase. There would be a second and a third data sets associated with each of the trial events. Those would be data sets that would form the basis for scoring in trial event number 1 and trial event number 2, and will only be released after the conclusion of each trial event. And then finally, there would be a final data set at the end of each phase that would form the basis for the official scores. I should say our initial assumption is that the vast majority of these data sets will be provided by the project teams that we're funding under the Grid Data program. However, we are very open for suggestions for where else we might be able to get high-quality data sets that have all of the detail within them required to be able to host the competition using the formulation that we've laid out in the RFI. So I'm not going to spend a tremendous amount of time going through the specific specification, but we've tried to lay out a detailed modeling approach and a problem specification in the RFI that is a fairly generic OPF problem, but we've tried to also lay it out in a way that makes it accessible to a lot of different communities. And so if there's something here that is very confusing or very non-standard, or you're really uncomfortable with it, especially if you're coming from outside the power domain, please let us know as soon as possible. This has all of the standard constraints that you would expect to find in an OPF problem, but it also has explicit behaviors under contingency cases. And this is worth a little bit of time to go through in slightly more detail. This was something that we really struggled with in the preparation of the RFI. Each of the data sets, so each network and scenario pair, within each scenario, there will be a definition of a set of contingencies that have to be respected. And each of those contingencies will define the loss of one or more elements in the system that will be suffered under a contingency case. And along with that scenario will be specified a set of participation factors covering some subset of the generators in the system, or perhaps in some scenarios, all of the generators that are defined. The real power changes that occur immediately after contingency occurs is governed entirely by the participation factor of each individual generator and the overall power mismatch that results at the end of that contingency, when that contingency case solves. These participation factors are representing several different actions that all occur in quick succession immediately following a contingency. After that change, based on the magnitude of the participation factor and the power mismatch for each contingency case, real power generator limits have to be respected, as do reactive power limits as well. Unfortunately, with high-fidelity modeling, voltage and reactive power outputs at generators after contingency is something that is somewhat complex, and unfortunately there is, as far as we could tell, no set formulation that's widely accepted in the community for how to model this in the context of an OPF problem. So we have tried to come up with a reasonable and logical way of modeling these changes. After contingency occurs, the voltage magnitude of each generation bus will preferentially equal the voltage determined in the base case, if doing so could be achieved within the total reactive power limits at that bus. So this is equivalent to generators reacting to a local voltage change and adjusting reactive power support accordingly to maintain the voltage at its original base case position. If that's not possible, aggregate local reactive power will then bind either the lower bound or the upper bound, and the bus voltage will adjust away from its nominal base case value. Competitors must give solutions where the post-contingency control variables satisfy those conditions, and at all times, voltages have to be maintained between the minimum and the maximum set as the limit. So ultimately, the binding constraint here has to be the voltage stays within the bounds. Let me get to the last point later on what competitors will have to send us. So I tried to do a very quick overview of how we've laid out the problem. There's a lot more detail in the RFI, and we really do seek detailed responses from the community on what are we missing, what have we left out, or is there some way that we've modeled this that is going to inadvertently exclude certain solution methods or exclude certain approaches to solving this problem. I should say that in laying out the specification in the RFI, we have tried to be as solution method agnostic as we possibly can. It is our expectation that competitors in the competition will use some other different related formulation to the one that we've laid out here, that takes advantage of the particular solution method or is particularly effective and efficient to actually compute. However, at the end of the day, all competitors, regardless of the formulations they use inside their own software, will have to provide a final set of generator and other equipment set points and control decisions that satisfy the formulation that is specified in the RFI. This ensures that every competitor across the entire competition ultimately is being judged against the same formulation, but some of the innovative work that will lead to good solutions is entirely likely to be part of the modeling within the individual problems. So let's move on to scoring. Scoring's been another difficult area as we've tried to understand how do we actually compare the multiple attributes that good solutions have. And what we're seeking is a fair and transparent, unambiguous, and quantitative method for scoring or ranking different solutions. So far, we've identified 3 important solution characteristics that we believe should be considered in scoring. First is the objective function value. Second is the time to convergence. And then third is constraint violation magnitude. Let me say a couple things about each of these. So objective function value obviously is the cost of the solution provided by participants. The time to convergence is going to be the time that's required on the evaluation platform from the moment we allow a piece of software to start working on the provided data set to the moment that that piece of software provides back to the competition platform a complete set of control decisions. That's it. That is the time to convergence. So in theory, teams that could be a very well converged solution, or it could just be a set of control decisions, some of which were made via optimization, some of which were made via an investigation of the structure of the problem is entirely possible. And then finally, constraint violation magnitude. We have not yet specified exactly how we'll come up with a score for constraint violation magnitude. But this is likely to be, and I believe we do have some details in the RFI for how this is done, it's likely to sum the magnitude of violations across a full set of different constraints. So for example, let me just give one example related to voltage magnitude. Each bus will have a maximum voltage magnitude that has been specified in the data set, and if certain buses in the power flow solution that is provided have voltages that exceed that voltage limit, we would take the magnitude of that difference and then sum that across all of the different buses throughout the system. Of course, you can think of far more complex methods for weighting, particularly high voltages, much worse than minor violations. We've had a lot of conversations with folks in the community about trying to find a way to differentiate between soft constraint violations and hard constraint violations that can never be violated under any circumstances. We've really had trouble finding a consensus view on exactly how we should treat different constraints. So it is something we are looking for feedback on, is exactly how should we calculate the magnitude of constraint violations, and how strongly should we penalize constraint violations as well. Indeed, we do not know yet in the data sets that are emerging from the grid data program if the vast majority of those cases will be cases that can be solved without any constraint violations whatsoever, or if this will just simply be a fact of life. I suspect, based on past experience, that we will have constraint violations in the vast majority of cases, but you certainly would want some of those to be penalized in the scoring method. So there are a number of different ways we could take scoring, and we've proposed 2 straw mans. Let me walk you through those 2 straw mans briefly. The first one, for each network and scenario pair, the best 20 solutions, and here we are specifying physical solutions, which means converged power flow solutions. The best 20 solutions in runtime, the best 20 in objective function, and the best 20 in the magnitude of constraint violations receive a positive score. A solution that violates what might be called a hard constraint, we have not specified what those might be yet, or doesn't provide a converged or solved power flow solution, immediately gets a score of -75. For each of the criteria, runtime, objective function, and constraint violations, the top 20 solution values, the magnitude of those values, across all competitors are linearly remapped to a high score of 25 and a low score of +1. So if I have the fastest runtime to provide a physical power flow solution for a particular network scenario pair, I will receive 25 points for that particular solution. Similarly, if I have the lowest objective function, I'll receive 25 points. As long as I'm in the top 20, I get positive points that is linearly remapped through the range of the top 20 from +1 to +25. I've provided a table here to allow you to work through some of the details for what this might look like. At the end of the day, a solution that achieves the best objective function value, the shortest runtime, and the lowest magnitude of constraint violations simultaneously would receive a score of +75. So the highest you can score on a particular individual network scenario pair is +75. And then solutions would be summed across all of the network and scenario pairs that are being scored at any given instant. And we would come up with an aggregate score for a particular algorithm or solution software across all of those. Part of the goal here is to ensure that an algorithm is not particularly good only for one type of problem. So ideally, we would be having good solutions and great solutions across a wide variety of different network scenario pairs throughout the competition. That's the first straw man. The second straw man is a little bit different. And this, we are trying to find solutions that are Pareto optimal in those solution constraints. And so the way we would score here is we first set a criteria for solution consideration. These would be, it has to provide a power flow solution, a reasonable power flow solution. It has to have we would set upper bounds on objective function, time, and constraint violation for a given network and scenario pair. And then each algorithm that is Pareto optimal, in the sense that any other non-scored algorithmic solutions are not a simultaneous improvement on any of those three characteristics, would score +1. This is plotted for 2 of the dimensions in the upper right here to try to demonstrate what we mean by this. Here you have a cloud of different solutions that all have different characteristics to them, and you see all of the red solutions are ones that for this particular network scenario pair would receive a score of +1. Solution that violates power flow or hard constraints would score 0 in this particular scenario, and the final score is determined by summing across all network and scenario pairs. Let me stop here again. So what I've gone through since our last stop was the detailed specification, and then discussion of the straw mans that we put together for scoring, and I'd welcome any detailed questions any of the participants have.
So I know Carlton has a question. So Carlton, I have unmuted your line. Do you want to ask your question?
Oh, yeah, sure. So I was just curious, when you're talking about constraint violations, why it's not been considered to have no constraint violations?
So we thought about that, and the simplest answer is that what we've been told repeatedly by folks in industry who we've talked to is that constraint violations are a fact of life, and you're going to have them based on the accuracy and precision of modeling, for example, or other factors. And a good solution really should try to minimize those constraint violations across the system. So it's a more aggressive, it would be a more aggressive problem to require that no constraints ever be violated. And there may be certain cases that come out of the grid data program where you can solve for a power flow without violating any constraint throughout the entirety of the system. However, we suspect that may be unlikely. So we'll see when we get there. I would be curious to receive other feedback on whether that's the right choice or whether we really should adopt a much harder stance to disallow any constraint violations, at least to the precision of what machines can give us.
sorry.
Tim, this is Jeremy from PJM. So my question is, like, you're not really sure which strawman methods you're going to use eventually?
We don't know. We're looking for feedback. We have gotten ourselves to the point where we have these two strawmans and have talked them in circles for months and can't decide between them. So we're looking for help, or we're looking for a different scoring method entirely. If there's, a different scoring method that would make the competition more relevant to the needs of industry, we are very open to considering that.
Thanks, appreciate it.
Here we have another question asking, sorry, just one moment, I think I just unmuted your line, Mr. DeCastro. Would you like to ask your question?
Yeah, considering that the solutions will be done on, on our separate machines, how are you going to compare runtimes?
That's a good question. I will actually get into that next when I talk about the evaluation platform. So please hold that question for another 5 minutes. Okay, great. So let's keep going, and this is a natural lead from the last question. So obviously, in problems where runtime is important, you really want to be able to compare fairly different algorithms that are, at least in their native development environments, are likely to be running on vastly different systems. So how do you solve that? The solution we found thus far is to build a separate and independent computational platform. And the idea is that we will be requiring all competitors to submit their solution software to this platform for formal evaluation. And so competitors will interact with an online portal, an online website throughout the competition for the purpose of evaluation. We're hoping to make an initial beta testing version of that platform available soon, hopefully perhaps by the end of the year, but perhaps in January. And that system is really split into two parts, a web front end and a back end algorithm execution and scoring platform. So the next couple slides will walk you through what we know so far about how that would look like. On the website front end, users will be able to find, of course, complete information on the final competition design, including the final problem formulation, data sets, submission requirements, etc. You'll be able to register as a competitor, download publicly released problem data sets, and it is intended that you would download the problem data sets that are available thus far, and you would do development on your own systems. It is not envisioned, and we're not hoping you will do development on the competition platform. We simply would not have the computational resources to enable that. The website front end will also allow you to make software submissions for evaluation and scoring, and I'll talk about how we're going to do that. And then we will maintain a set of leaderboards throughout the competition on all previously submitted algorithms, so you know throughout the competition where you stand relative to other competitors. Most of the website will be accessible without an account. We're trying to have this be as broadly applicable to everybody as possible, but registration will be necessary to participate as a formal competitor. And in many instances, formal registration with ARPA-E will also be required to participate, and we will be releasing details on how to do that when and if we announce a formal competition. We have described the core functionality of the website and the web portal in the RFI. We're very much looking for ideas or for enhancements or other things we can do to make this more approachable to a wider range of contestants, particularly keeping in mind those who may not be coming from this particular domain to start with. We would also welcome any feedback people have once they start working with the competition platform once we release the beta testing site. When we release the initial website for beta testing, we will have a set of small systems that are available for immediate download, and we will make it available such that potential competitors can submit code and formally be scored against those small test cases. These are just going to be slight modifications based on test cases that are already out in the public domain. In order to compete, competitors will first have to commit competition source code or compiled software to a GitHub repository. In most cases, we're expecting that teams will want to set up a separate GitHub account specifically for the competition. Competitors will then log into the competition website and use the submission request page to initiate an algorithm evaluation cycle. As part of that evaluation cycle, you will have to grant read access to that GitHub account to the evaluation platform, and the evaluation platform will provide an SSH token to be used for that purpose. The competition platform will then reach out to GitHub and pull in the software that you would like to have evaluated. And for competitors who want to submit source code, you'll have to specify the language that you would like the script to evaluate that source code with. And we're still working through the details of what additional information we might need to be able to run fully compiled software. I fully appreciate the fact that many competitors are not going to be willing to provide any detail on exactly what their method is. And our goal throughout the design of the competition is to ensure that we're setting it up in such a way that you will not have to disclose any of those details if you don't wish to. But some teams will likely submit source code as well as part of this. We've designed the execution platform for the competition, and we're in the process of designing it to enable high consistency of computational performance and fairness between all competitors. And before we release the beta system, we'll release statistics on the experiments that we've done on the platform to ensure that that is the case. So the entire backend is built on a Java Play framework, and we're planning to run all of the actual competition code within Docker containers. And the Docker instances will allow, of course, the code to run natively on the underlying Linux kernel, and the hope is that there will be little or no performance overhead in doing so, and that performance overhead will be consistent across all competitors' codes. I should say we have a dedicated small-scale cluster for this purpose, and each Docker instance will be running on a specified subset of that cluster with nothing else running as well. So the whole goal of the design of that competition platform is to ensure that we have consistency of runtime. Within that Docker, codes will be completely denied all network access. And the file system will be restricted to only those directories that contain the data set and other needed information for the inputs to the competition software, and then the directory where competitors will be asked to write their output files corresponding to all of their decisions. It'll be a quite controlled environment. You won't have access to the outside world, but we are planning to make some standard software available within that Docker instance, and this is another area where we're looking for additional feedback from the community on what should the baseline set of software be that is housed within that Docker instance. What do you need that's available as standard software that we can go out and procure to include within the Docker instance? We want to be as inclusive as we possibly can, so please do give us your suggestions. Again, so we'll have to work through the licenses for all of that software. In some cases, there have been a number of vendors who have already stepped up and offered common software packages or solvers available to the competition platform. In other cases, you may have to provide a license to run a particular custom piece of software for your evaluation run, or we would have to go out and get that license. So that'll be handled very much on a case-by-case basis with competitors, and we'll announce more details on how we'll go through all of those cases later. But if you see problems with that, please let us know. Let's talk it through. In particular, if you've got one particular piece of software in mind and you're worried that it simply is not going to run within this Docker instance the way we've described in the RFI, please do let us know as soon as possible. I've talked through a lot of this so far. So we do intend to make a number of common software packages and solvers available by default in the competition platform, and we've been really excited to have several organizations already agree to sponsor the competition and offer their software for use and inclusion within the competition evaluation platform. We are looking for active feedback regarding any additional software tools that might be out there. So let me walk you through just a little bit more detail on that. So this will be, eventually we'll have a web page that's up and running. Let me also take this moment, I meant to say this earlier, but let me take this moment to thank the organizations that are helping in the design of the competition. So ARPA-E has been working with individuals at Pacific Northwest National Lab, Arizona State University, and the University of Wisconsin-Madison, and they've been instrumental in helping us think through how to set the problem up, how to choose the right formulation, and had been helping us through the design and implementation of this entire evaluation platform. Indeed, it's envisioned that the computation evaluation platform will be hosted at Pacific Northwest National Lab. We'll have various sites, of course. We're planning to have active discussion forums, frequently asked questions for use throughout the competition, and competitor registrations. This provides a little bit more detail on how the code for competitors is pulled into the competition platform and then executed. And I'm going to skip this because it's going to take far too long to describe it in full. Let me say a little bit about what we actually mean by evaluation. What we're asking competitors to provide, and what you'll see in the RFI is the description of two different timers, and I apologize if that section of the RFI is a little bit confusing. When we launch a competitor's code to initially start to solve this problem, we're going to start first a timer. And at the end of that timer, we will stop that timer when competitors have provided the control set points for all control equipment throughout the system and their objective function value. So all a competitor has to do is provide us with a vector of decision variables and the objective function value, and then we're done, or they're done for the first set of timing. However, after that timer stops, we're then planning to ask competitors to continue to run computations in order to calculate full power flow solutions for their code. And the reason we have opted to do this is just because different power flow packages that we might use as underlying the competition platform very well may have trouble finding certain solutions under some conditions, even if the solution does exist, and different packages may find different solutions given the same inputs. And so it adds a level of arbitrariness to the scoring that we really were uncomfortable with and couldn't find a good way around it. So what we're asking competitors ultimately to provide is real and reactive power generation with each generator, real power injections and withdrawals, reactive power injections and withdrawals, voltage magnitude and phase angle at each bus for the base case and for each of the contingency cases, and the system-wide power imbalance magnitude for each contingency case. So keep in mind, we're not requiring all competitors to calculate all of those values before the official timer stops. Most of those values will actually be calculated after the fact, after the timer has stopped. The timer will only record computation time required for competitors' codes to provide control set points. We will use a second timer to track the additional time required to provide contingency set point decisions, system-wide power imbalances for each contingency, and power flow for the base and all contingency cases. But at this moment, we're not planning on using that second timer for any scoring purposes. The reason that that second timer becomes important, of course, is that many solutions and many of the higher performance codes that people submit will likely ignore or screen out many of the contingencies that have to be monitored for any given problem. And we don't want to force teams to calculate power flows or calculate solutions for contingencies that they have a heuristic that knows that they should ignore that if indeed that heuristic works. And so we will penalize if you violate a constraint that you didn't know about, but we shouldn't require you to go through and calculate every single one of those while the first timer is running. The evaluation platform will then take all of the solutions provided by competitors and will first check to make sure that all of the values you have provided are a power flow solution. So this is just a forward evaluation script that will run against all the inputs that you've provided, and just to ensure that you're satisfying the system equations that is formed by the full power flow formulation or OPF formulation that we've provided. Once that is done, it will then score both the objective function value as well as all of the constraint violations. In terms of eligibility, actually, let me stop there and see if we have any questions on the procedure that we've laid out for evaluation.
Yep, just as a reminder, if you have a question, you just go through your private chat box on WebEx and message me, Natalie Joubert, the host, and I will open your line to allow you to ask a question.
Okay. So in terms of eligibility, this is another area we're looking for feedback from the community on. ARPA-E does intend to encourage domestic and international participation in the competition. It's anticipated that individuals can enter on their own as an individual, or a competition team can consist of multiple individuals and or multiple organizations. Each competition team will have to have a formal entrant, which will be either the lead organization or an individual. And in cases where the entrant is an organization, an individual team leader will have to be specified. ARPA-E, we are proposing to allow but not require teams to enter under an official affiliation. So you can join and form a team using your company's official name or your university or your research group's official name, or you can make one up. And we're seeking ways to ensure that the competitors can be, at least until they want to receive a prize, they can be anonymous to at least some degree throughout the competition. And teams also may have official sets of sponsors. It's allowed and encouraged under a lot of federal government competitions in the U.S. We're still considering the question of eligibility of individuals, and we may end up requiring entrants to be a U.S. citizen, permanent resident, or a U.S. company that could, of course, be a subsidiary of an international company, just like with most of our regular funding programs at ARPA-E, and they would have to have that affiliation to receive a prize. This certainly does not say anything about the status of any other team participants or other team partners. So you certainly could have a team that was led by a U.S. individual, but then partnering with folks throughout other countries around the world. The prize eligibility would be determined by the team lead. We could also consider opening this up. We may have authority. We're still researching the specific authorities that we have as an agency. We may be able to open the prize up to any entity worldwide, subject to a couple of restrictions that the federal government has. And we would be curious to know the feedback from everybody involved on where we should draw the line on eligibility. We will, I should say, publish a very detailed set of comprehensive eligibility rules prior to the start of phase 1. Okay, I think it sounds like we have 2 questions, so let's stop there and we can go to those 2 questions.
Yeah, the first question we have is from Carlton regarding computational specifications. Carlton, do you want to elaborate on your question?
Yeah, so I was just curious if you're going to be evaluating on hosted hardware, what's the ideas for what that hardware looks like? For example, if it doesn't have enough cores, it may be biased against parallel. If it doesn't have a graphics card, algorithms which could take advantage of that would not be able, would not have that advantage. So what are the thoughts on that?
Sure. So I actually don't have those details right at my fingertips, and I'm wondering if anybody else on the call does. Do we have anybody from P&L on the call who knows those details? I don't want to quote something incorrect. Let's wait and see if they contact Natalie.
Yeah, they can contact Natalie through the messaging platform.
It doesn't look like anybody's here right now. So, Carlton, let me follow up with you on that, and anybody else who's interested in the details of that, please let us know. The general...
Stephen can answer. Hold on just one moment, Stephen, and I'll unmute you and we can better address this. All right, Stephen, you should be live now.
Yes, Carlton, at the moment, the evaluation platform consists of a 24-core dual chipset from Intel. We have 3 or 4 of those. At the moment, we do not have a graphics device integrated with the evaluation platform, but that is an option that we will investigate if there's sufficient interest. I should also add that the interconnect between the 24-core nodes is a FDR InfiniBand with approximately 6.5 gigabytes per second bandwidth.
Are you saying that the algorithm can be distributed across multiple computers?
Across multiple nodes, yes.
So that will be available to folks if they so choose and they would like to use it. Obviously, it does still set an upper bound on what's possible. So the idea here is to use a fairly hefty machine or a fairly hefty set of machines, but not to use the full capability of a huge machine that would be unreasonable to expect that somebody would actually want to use in industry.
Okay, I guess I'm just a little bit more confused now. The Docker-based model that was being explained sounded like one algorithm running on one machine, but I just heard something more like a distributed algorithm. Can you just clarify, like, all the resources that are available to the algorithm?
Steve, do you want to repeat what you said?
So Carlton, we're still, part of this is we don't know what kind of environment people want to submit to. So we've set up a 4-node InfiniBand linked set of nodes. There are some options that we're investigating that Docker could control multiple nodes, that each node is 24 cores. So okay. Fundamentally, does that help? Or?
Yeah, that's much clearer. Thank you.
Okay, great. And we have one other question.
Sure, yeah, the next question we have is from Cesar. I've opened your line if you'd like to ask.
Oh, yeah. Hi, this is Cesar from Sandia National Labs. I was just similar to what the question before was as far as parallel computing capabilities, if the limitations are, what the limitations are, but Steve kind of touched on that, so.
Great.
Thanks.
And we are certainly seeking feedback on that. So if you're anticipating that your algorithm will need a larger machine to be competitive within certain reasonable limits, please do let us know. And if we do get a lot of interest in that, or if you're looking for some other architecture or other architectural decision, please let us know, and we will evaluate all of that. We really do want to design it such that we are excluding as few people as possible.
Sounds good. Thanks.
Okay. So let's go on. I think this is really the last slide I have before the specific RFI questions, and this is sort of the million-dollar slide, if you will. We're planning 2 phases. And I talked about those phases earlier, but when it comes to actual competing, one of the pieces of feedback we've heard loud and clear from a lot of folks out in academia and national labs and even parts of industry is there are certain organizations or certain circumstances in which one would not be able to find internal resources to be able to compete in a competition like that. And so we're actually adopting a form for the competition that's been used successfully over at DARPA, where for each phase of the competition, we're intending to have 2 tracks, what we call the open track and the proposal track. The open track is open to anybody subject to the eligibility requirements I spoke about on the previous slide, and they're receiving no funding from ARPA-E for the purpose of supporting their efforts to build software for the competition. So this is truly open. And then prior to formally starting the competition, we would run a FOA, standard funding opportunity announcement, similar to what ARPA-E does for most of our programs. And that would be to build out what we're calling the proposal track. And so we would solicit applications. In that application, we would be asking for a high-level overview of the method or methods that you're planning to investigate and pursue for the competition, evidence of prior success, if any, preliminary data on other problems, description of your team and the qualifications that your team has and why you think that you could be particularly successful in this particular effort, and then also an indication of why it's so important that you receive funding to work on the competition. So what is it that's preventing you from being able to put your own resources towards competing? And the idea is that we would then select from among all of the applications using very clear merit review criteria similar to all of our FOAs, roughly 10 teams, and each of those 10 teams would receive a $500K one-year grant that would be expected to be used for teams to compete in the competition. We would then go through the first year. All of the trial events as well as the final event would be open to both open track and proposal track teams. And indeed, for most of everything we'd be doing on the evaluation and the competition platform, et cetera, we actually would not differentiate in any way between open track and proposal track teams. The algorithms would be scored exactly the same way using the exact same criteria and the exact same data sets. After the final event, when all the dust has settled, we would determine the top 10 competitors in that first phase of the event. So the top scoring teams across the final data set in aggregate. For those in the top 10 that were part of the open track, what we're envisioning is that they would immediately win a $500,000 prize, subject to some requirements that will be specified in the design of the competition. For example, the DARPA programs that have used similar structures to this often require a technical paper to be submitted to the agency so that we know that there is something that you've actually done. Sometimes there's a site visit requirement as well, so we're considering all of that. But open track teams would win $500K in prize money. Proposal track teams, if those proposal track teams are in the top 10, then they would get a second additional $500K grant to participate in phase 2. And so what you see here is we're giving the top 10 teams $500,000. Open track teams get that as a prize. Proposal track teams get that as a grant. And it's envisioned that the 10 teams who receive the $500,000 of funding at the end of phase 1 would be some combination of open track and proposal track teams. Those two tracks would then compete in phase 2, and it's not expected that we would run a separate funding opportunity announcement for proposal track teams in phase 2. To be in the proposal track in phase 2, you had to perform well in phase 1 and end up in the top 10. But we're envisioning that the open track would continue to be completely open, and you would not have had to participate or win in phase 1 to be able to participate in the open track portion of phase 2. We would then run all the trial events and the final event in phase 2, again using the exact same scoring criteria, exact same structure, exact same data sets for both open track and proposal track. And then there would be 3 winners that would be determined at the end of that final event. And the current numbers that we're proposing in the RFI is that the first place team would win $2 million, second place team would win $1 million, and the third place team would win $500,000. Really the idea here is to establish the practice of running competitions for problems in this domain space. And my hope is that the evaluation platform that we build for this effort could be repurposed for various other competitions, either future competitions supported by ARPA-E or competitions that are built, designed, and sponsored by other organizations such as those out in industry or academia. So it's entirely possible that ARPA-E would continue to fund future prizes, either in this domain or related domains and related problems. But the hope is to convince the rest of the community and perhaps even other parts of the Department of Energy that this is a particularly effective way to run competitions and benchmark different solutions. And so hopefully this will become a standard practice that complements all of the other programs that the department runs. So all I have left is the specific questions that we detailed out in the RFI. I don't think I need to read those as part of this now. I think you can find all of those. But I will, throughout the rest of the Q&A, I'll leave these up and I'll cycle through the rest of them as well. So if anything catches your eye and you want to ask a specific question, I'm more than happy to answer. So I think with that, I will conclude the formal presentation, and we have about 25 minutes remaining for additional questions.
Hi, yes, our first question is from Russ Philbrick. Russ, your line is open if you'd like to ask your question regarding phase 2.
Thank you, Natalie. So, Tim, phase 2 is talking about unit commitment, but it sounds like you only are going to go to the phase 2 as a competitor if you pass the phase 1, which is AT-OPF. Those are two very different domains of expertise. Doesn't that create a problem for getting the right expertise on each of those two problems?
I appreciate that comment, Russ. It is something we've struggled with, and one of the other options that we've considered is truly splitting this into two separate phases entirely, such that we go through the first year, we have certain prize money available for OPF, we then go through the second year with a vastly different set of teams. I suspect that when you look at the details of the OPF formulation that we're selecting, it's already going to cause some of the problems that you would traditionally associate with a unit commitment problem. And so it may actually end up that you're engaging parts of the same community, even though that wouldn't have been what you did traditionally. But that's subject to further consideration. So I'd welcome additional feedback on, should we split those, should we really separate them out, or should we turn our focus to a more complex version of the OPF problem and double down on OPF and do it 2 straight years to make sure we really do get the critical mass we need to have an impact.
Thank you, Russ. If anyone else has a question, please send it to me in the chat box. My name is Natalie Joubert. I'm the host, and once you send me your question or your desire to ask a question, I will open your line. Yep, looks like we have another question from Carlton. Just give me 1 second, Carlton, and we'll open your line for you.
Actually, let me say one other thing to that previous question. If you, and this may be an opinion that's shared, if you feel that the unit commitment problem is a far more important and pressing problem and could be modeled transparently in a fair way, similar to what we've tried to lay out for the OPF problem, we certainly would encourage folks to send us feedback that they think the entire competition should be focused on unit commitment and not OPF. If you feel otherwise, that we really should focus on OPF, please send us your feedback on why you believe we should focus on OPF for the first phase. We are open to that discussion as well, whether or not we should focus both phases on unit commitment or both phases on OPF. I believe they can both be done effectively. Next question.
Sure. Carlton, your line is open.
Yeah, I wanted to ask a question about the formulation. So why haven't things like transformer control and bus shunts and line switching been put into the current OPF form?
So I have to go back through the details. I believe they are inserted via the Y matrix. The idea is that we would include them as part of that. Ultimately, the reason that we struggled to include them in the formulation at this early phase is because we don't know what data set format we're going to use, and so we don't know exactly how that information will be specified in the data sets. Once we finalize the form that the data sets will take place, it'll be much easier to go back and include them in the formulation. We do mention that aspect in several places in the RFI, but I agree it's not called out as clearly as it should be.
So maybe I can clarify the question. So given the Y-bus matrix that's in the RFI, you can incorporate those type of devices as static parameters. But what you can definitely not do is incorporate them as control.
I would need a separate table or parameter in some way to specify them, yes.
But not only that, I mean, there's no decision variables, right? The decision variables are like V and theta, not transformer, tap, and shift.
Say that again. I'm not sure I agree.
Oh, well, okay, maybe I've quite misunderstood the RFI formulation, but my understanding is that the B values and the G values are constant, and the only other remaining terms in the flow equations are theta and V, and that would imply that, like, you fixed all the bus shunts and transformer control parameters.
Yes. So, but that is as a competitor you've specified. So we have not told you how we will describe the vector of tap positions, right? But and I admit that it's probably not described well in the RFI in the current version. But the idea is that we will provide you with a description of a certain transformer, and we'll say, you know, this transformer has the following tap positions, and you have to select between them.
Okay, so what I'm hearing is that
you're not directly choosing the voltage, you're choosing the tap position.
Right, so what I'm hearing is that these will be decision parameters in the formulation, even if I didn't see it in the RFI.
It has always been our goal to have them there, and I don't think we've described that sufficiently right now. That's exactly right. If you have a particular method that you would recommend that we represent those decision variables, we would very much appreciate that feedback.
Okay.
Thank you, Carlton. I have no other questions. Again, if you have any questions, please message Natalie Joubert through the chat box.
Okay. Let me flip all the way through to my contact. So I'm now displaying my contact information on the screen. So if you would like to have a follow-up conversation to discuss in a little bit more detail any of the aspects that we've described in the RFI, please do reach out to me via email, and we can try and find time for that over the next couple weeks. Again, I encourage you to not use that as a substitute for providing detailed feedback. Written feedback that's submitted formally to the RFI is something I can share with all of my colleagues here at ARPA-E, and is also material that I can use in support of this competition to ARPA-E's leadership team. I'll be the first to admit that there are many gaps and holes that exist in the current form of the RFI. I think Carlton just pointed one of those out very effectively. We're trying to find all of those and fill them, and we need to be able to convince ourselves that we've sufficiently filled a lot of those gaps before we would make a final decision on whether or not to proceed with the competition. I'd also just reiterate the fact that the RFI responses are really being used for two purposes. One is to help ARPA-E decide whether or not this is something we should do. And so we're looking for feedback on what could the potential impact of this be. Have we set up the problem in such a way to maximize that impact? And then the second goal here is to ensure that we're designing it well enough to maximize that impact. So we're looking for feedback on both of those. And I believe the formal questions we've included in the RFI should be a guide for how to answer all of that. So if we have any other questions, it looks like we do not have any other questions. So let me thank you again for all of your support throughout this entire process for program design. Really appreciate the time everyone is taking to read through the RFI and consider all the details, and taking all of the time to send us formal written responses. We do encourage everyone to submit those responses as soon as possible. We are reviewing all of the responses on a rolling basis, and we do expect to be inundated on the 22nd. So early submissions would be very much appreciated by my team and everyone else here at ARPA-E. Please do let me know if you have any other questions, and thank you so much for participating.